I'll begin the second video with question number 10. Again, this is an inequality. I'm going to factor the denominator. And I can see that I have two vertical asymptotes. X equals -5, x equals -2. I have a 0 at 3. These are disruptions to the x-axis, so I'm going to make myself a number line with these disruptions in order and check for numbers below, between again, and above. And it turns out that if I choose a number less than -5 and substitute it into the equation, I get negative values. If I choose a number between these two, for example, -3, I get positive values. If I choose a number, for example, like 0, between these two, I get negative values. And above 3, I have positive values. Looking at my equation, I need values of this equation that are greater than or equal to 0. That would be positive values. So to write my answer, I'm going to choose values of x that are between -5 and -2. And since these are asymptotes, I cannot include the -5 and the -2. However, 3 is a 0, so I could include this 3. And I can pick values that are 3 or greater. Going to number 11. Number 11 is asking for a partial fraction decomposition. So I'm going to decompose this fraction. The first thing I'll do is factor the denominator. And it factors into x minus 3 times the quantity x minus 2. So I'm going to decompose this fraction into a fraction that has a denominator of x minus 3 and another fraction that has a denominator of x minus 2. My process then is to get common denominators so that I can cancel all the way across, and it will leave me 13x minus 31 equals a with some factor and b with some factor. So I'm going to multiply a times x minus 2 and b times x minus 3. Since the denominators on both sides of the equal sign are equal, I can multiply both sides by that denominator and they are gone. That will leave me 13x minus 31 equals a times the quantity x minus 2 plus b times the quantity x minus 3. I'm going to distribute. I have ax minus 2a plus bx minus 3b is equal to 13x minus 31. I'm going to group my factors, or excuse me, my terms now. And somehow I've ended up with 13 as some relationship between ax plus bx. And I can end up with an expression, since x now becomes irrelevant in terms of how I got the 13 with the coefficients. 13 equals a plus b. I have -31, and that was obtained by combining a minus 2a and a minus 3b. I'm going to do a system of equations to solve for a and b. I decided to multiply the top equation by 2. and use elimination to solve for b. And I find out that b is equal to 5. I substitute back into this equation, and I have 13 equals a plus 5. So a must be 8. Then I can write the two equations decomposed as negative 3 over x minus 3 pardon me. I can write the two equations as 8 over x minus 3 plus 5 over x minus 2. And there's my answer. Going on to number 12. Number 12 again is a decomposition. I factor my denominator. So this will give me negative 9 over x minus 2 times the quantity x plus 1 will equal a over x minus 2 plus b over x plus 1. Getting common denominators. I now can eliminate this. Negative 9 will be equal to a times the quantity x plus 1 plus b times the quantity x minus 2. I'm going to distribute. This is ax plus a plus bx minus 2b. I have no x term over here, so I know that a plus b must have been equal to 0. And my other term would be a minus 2b. When I solved this, I decided to multiply through the bottom equation with a negative 1. And I found out that b was equal to 3. And if I substitute back into the original equation, then a was equal to negative 3. So my decomposition was negative 3 over x minus 2 plus 3 over x plus 1. Moving on, finding the limit. I'm going to a factor again. The numerator factors into x minus 2 times quantity x minus 3 over x minus 2 times x plus 10. So you can see that the reason I'm using a limit is that I am undefined. At 2, it's a removable discontinuity. In order to be able to find the limit as x approaches 2, we remove the discontinuity and substitute 2 back into the equation. When I do, the numerator becomes negative 1 and the denominator becomes 12. So the limit as x approaches 2 after I remove the 2 from the equation is negative 1/12. Moving to number 14. Number 14, when I graph the ln of x, I know that the general equation for the ln of x would be something that looks like this. So it says it has a domain of all positive real numbers, and that would be true. The ln of x increases without bound as x increases without bound would also be true. The graph of e equals negative x is the graph of f of x reflected about the y-axis, and that is also true. However, for this one, e to the negative x has a range of all real numbers. Well, we realize that this equation would be an equation that would look like this, and a range of all real numbers would not be true because you can see that we have nothing lower than y equals 0. In fact, y equals 0 is an asymptote, so we don't even have y equals 0. So D would be the best answer for this one. Number 15, which of the following is equivalent to the log base 5 of 5 over x cubed? We'll use our expansion equations. And we know that if this is being divided, that I can rewrite it as a subtraction. I also know that a power, using my properties, can be moved into the front of the expression. And I know that when the base matches the number here, the answer is 1. So I know that the best answer to this problem is letter B. Going to number 16. Again, I'm going to use my expansion properties, and I'm going to write this as log of y squared minus the log of the square root of x. I know that the power can move out in front. I also know that the square root of x may be written as x to the 1/2 power. So I'm going to move the 1/2 out in front. And the best choice for this answer would be letter C. Excuse me, letter B. Moving on to number 17. Which of the following is equivalent to 3 ln of x plus ln z minus ln y? Now I'm going to use the properties to put this all back together. So I know that this was ln x cubed plus ln of z means that they are multiplied together, and minus ln of y means it was divided. So my best answer would be letter C. Number 18, this is a change of base. Change of base has the log of 20 over the log of 2, which means originally I had log base 2 of 20, and that would be letter C. Number 19. Number 19 says write my answer to 3 decimal places. I used a calculator and a change of base. So I used log 6,904 over log of 7. You could use ln, and the ratio would be the same in both cases. The ratios are the same, the individual numbers are different, and both of them are equal to 4.543 to 3 decimal places. I used the same procedure for number 20. And you could use ln, and in both cases the answer to this one was negative 3.173.